The purpose of this video is to introduce you to the idea of indirect proof, sometimes called proof by contradiction. This is a really neat topic because there's a perfect real-life example that most people understand and can relate to, and that is the alibi. Just as you would use an alibi to prove that you were not in a particular place at a particular time, we're going to use indirect proof in order to show that something is not true. So I'm going to leave myself a little note here. Use to prove something is not true. And in writing indirect proofs, we're going to follow 3 steps. The first thing that we're going to do is we're going to assume the opposite of whatever it is that we're trying to prove. And I'm going to take a minute and highlight the word prove there because that's important. You want to make sure you start with the opposite of whatever it is that you're trying to prove, not the givens. We're then going to use the information that's given to us in the proof or in the problem to establish a contradiction. Hence the name proof by contradiction. A contradiction is going to be 2 statements that both can't possibly be true at the same time. And then the last thing that we're going to do is once we establish that contradiction, we know that our proof must be a true statement. So our last step is to conclude what we're trying to show is indeed a true statement. All right, and there's no better way than just to jump right into this, so let's go ahead and get started. In example 1, we've got those givens. We're given that segment AB is not congruent to segment BC. We're given that segment AD is congruent to segment DC. And we're trying to prove that segment BD is not perpendicular to segment AC. Now, the big clue in this problem that tells me that I'm going to have to use the method of indirect proof is that little word not in there. So there's my hint that tells me I'm going to have to prove this indirectly. If I go back and reread the information that I've been given, in that first statement, I've got that 2 segments are not congruent to each other. I don't have any way to show things are not congruent in the diagram, so I'm going to put that on the back burner for right now and use that to establish my contradiction later on in my proof. My second given, I can and will mark in my diagram. So let's go ahead and get those 2 marked congruent to each other. And that's about all that I can mark in the diagram from the information that's been given to me. All right, so let's go ahead and get started on this. We're told that these 2 segments are not perpendicular. And we know that the first step in writing a proof by contradiction is to start by assuming the opposite of whatever it is that we're trying to prove. So I'm going to begin my proof by assuming that segment BD is perpendicular to segment AC. And that is an assumption. So that's a new reason for us, but it's not a hard one. We're just making an assumption. And now that I've assumed that those guys are perpendicular, I'm going to go mark them in the diagram, and I'm going to see what happens. I'm going to see if I can establish a contradiction somewhere. Well, if those guys are perpendicular, the angles at D, angles 1 and 2, have to be right angles. I know that segment BD is congruent to itself by the reflexive property. And so now I can go ahead and use side angle side in order to demonstrate that the green triangle and the yellow triangle are congruent. I know that once triangles are congruent, all their corresponding parts are congruent. So now I know that side AB has to be congruent to side BC. And there's my contradiction because I'm given that those 2 sides are not congruent. And so therefore, it must be the assumption that led me to that conclusion that's a false assumption. All right, so let's go ahead. We're going to go ahead and begin by making those or writing about those congruent triangles. So I know from the picture that I have to talk about these 2 angles being congruent. I'm going to start by using the perpendicular lines that I assumed. So angle 1 and angle 2 must be right angles. And that's because anytime you have perpendicular lines, they form right angles. I know that those two angles have to be congruent. And that's because all right angles are congruent. So these should be reasons that you're familiar with. Nothing new going on here. The congruent triangles should be something that's old and familiar and comfortable to you. Somewhere in my proof, I need to write about segments AD and DC being congruent. And that's because those were given to me to be congruent. And also somewhere in my proof, I need to discuss the fact that segment BD is congruent to itself. And that's because of the reflexive property. So at this point now, I've discussed a pair of congruent angles and two pairs of congruent sides. I've set myself up beautifully to go ahead and state that those triangles are congruent. And once those triangles are congruent, I know that all their corresponding parts must be congruent. The parts that I'm going to pull out are going to be the parts that go along with my given. So in this particular case, the parts that I'm going to pull out from those congruent triangles are sides AB and BC. And that's by CPCTC. And here's where I'm going to use that other given. We're told that segments AB and BC are not congruent. That's a given. And here's our contradiction. Here's our problem. On one hand, we're saying that segments AB and BC are congruent. On the other hand, we're saying that segments AB and BC are not congruent. Both of those statements can't possibly be true at the same time. So it must mean that the assumption that led to that contradiction, in other words, this statement up here, is a false statement. If that statement up there is a false statement, then I know his opposite must be true. And his opposite is that segments BD and AC are not perpendicular. My reason there is the contradiction. I've shown two statements that both can't possibly be true at the same time. All right, so that was something new. It was something different, but it did use a lot of the old, familiar, comfortable concepts that we've studied so far this year in geometry. Let's go ahead and take a look at the second one. In the second one, we're told that segment BD and segment AC are perpendicular. So I'm going to go ahead and mark that. We're told that segment or triangle ABC is not isosceles. Since I don't have any way to mark that in my picture, I'm going to save that to establish my contradiction. And we're being asked to prove that segment BD does not bisect AC. And that word not, again, is very clear, very indicative to me that I'm going to need to use this method of indirect proof. All right, so for all you statement and reason people, this two-column proof is for you. I'm going to go ahead and begin my proof by making the assumption that the opposite of what I'm trying to prove is a true statement. So I'm going to go ahead and assume that the opposite, in other words, segment BD does bisect segment AC. My reason there, I'm making an assumption. I know that segment bisectors give me congruent segments. So if BD bisects AC, I know that segment AD has to be congruent to segment DC. That's what segment bisectors do. I'll cite statement 1 because statement 1 was where I had that segment bisector. And once again, I'm going to go ahead and I'm going to prove that these two triangles are congruent to each other. So somewhere in my proof, I need to talk about those congruent angles at point D. Again, I'm going to number them 1 and 2. I know those are congruent because of the perpendicular lines. So the fact that those guys are perpendicular is a statement that's given to me. That tells me that angles 1 and 2 are right angles. And I'll cite statement 3 because statement 3 was where I had the perpendicular lines. Now I know that angles 1 and 2 are congruent because all right angles have to be congruent. Next, I know that segment BD is congruent to itself by the reflexive property. And now I've talked about everything I need to talk about in order to establish congruent triangles. I've got a pair of congruent sides, a pair of congruent angles, a second pair of congruent sides. Now I'm all set up beautifully to conclude that triangle BDA and triangle BDC are congruent to each other. And here's where I need to go back up and use that statement that I saved. Somewhere in my proof, I want to be able to say that triangle ABC is isosceles. Well, if I use a pair of congruent corresponding parts from my triangles, I can make that triangle isosceles. I'm going to pull out side AB and side BC. They must be congruent to each other because once my triangles are congruent, I know that all of their corresponding parts are congruent. And if side AB is congruent to side BC, I know my triangle has to be isosceles. Any triangle that has two congruent sides is isosceles. So now I can go ahead and state that triangle ABC is isosceles. And that's because any triangle with two congruent sides is isosceles. I'm given that triangle ABC is not isosceles. And therein lies my contradiction. In one statement, I'm saying this triangle is isosceles. In the next statement, I'm saying that it's not. Those can't possibly both be true, and so it must mean that the assumption that I made that led me to this bad place where I've got these two opposite statements being true must be a bad assumption. So I can go ahead and conclude that segment BD does not bisect segment AC. And when I write contradiction, I am going to cite the two steps or the two statements where the contradiction exists. So the contradiction is there between the two statements that I've highlighted. All right, so I want you to, like always, in your own words, summarize what's important. What do you need to remember and recall from this video? Why did I feel it was necessary for you to invest 14 minutes of your precious life looking at this material? What's the important takeaway?